Okay, good morning, Math B Honor students. Today we'll be doing the 1.1F lesson on solving equations with absolute value. So you may have remembered absolute value from previous courses. We know that the absolute value is really the distance from the number inside the group or the number inside the absolute value bars. It's how far this number is from zero. And we know that distance is always positive. So therefore, absolute value bars are always positive. Okay, so -5 is right here, 5 is right here. They both have a distance of 5 from 0, right? So let's just write that down. Absolute value is really the distance a term is from 0. Okay, let's skip down to number 3. For what values of a is negative absolute value of a negative. So what's interesting about this is whenever you see a negative sign outside of an absolute value, we should realize that this will always be negative because we are not allowed to distribute the negative inside the absolute value bars. That's a really, really important thing to remember. You just kind of calculate the absolute value first, and then you attach the negative afterwards. So this will always be negative. It's kind of like the absolute value bars are like a group. It's kind of like a parentheses. You are not allowed to distribute a negative inside those. So it's a little bit different in that regard. So you kind of always have to calculate this first, then you attach the negative. So therefore, what values of a is negative, absolute value of a positive? This is, well, since this is always negative, all real numbers would make this negative, right? But since negative absolute value of a is always negative, none of the real numbers, no real numbers would ever make this positive. So this is, you could say something like never positive, and the technical answer would be no solution, right? Because there's no value of a that you could plug in that would make negative absolute value of a positive. Okay, so we just went over some rules. You cannot distribute a negative inside, and you always want to calculate the absolute value first. So let's go down to some quick practice problems. This, I read it as 11 times the absolute value of -14, right? You can kind of think of it as this. And you always calculate the absolute value bars first, okay? So this is really like 11 times 14. And 11 times 14 is simply just 140 plus 14, which equals 154. Okay, here we have -7 plus really 10, and this is just a 3. Okay. So 7 through 14, this whole entire page, excellent, excellent practice problems. How about you try 10, try 12, and 13 and 14 are good ones, right? So try these 4, 10, 12, 13, and 14. You could pause the video, but I will do them right after this. And yeah, I think these are really good practice problems. Okay, so the way I would describe doing them is first, you always want to kind of have your eyes set on what's inside. Whatever's outside, you can kind of ignore until the very end. And remember that, of course, you can still calculate negative values inside the absolute value bar, it just will reverse to its positive counterpart. So for something like number 10, you have to do 12.5 minus 20.9. And what is that exactly? I'm getting it to be, is that 8.4, but it's negative, right? It's kind of like you have $12.50, you spend $20.90, so you're in the negative, and you're negative 8.4, but then the absolute value bars make it positive 8.4, but then there is also a negative that you attach, and the final answer is a negative 8.4. Right? Without even doing any calculation, you should have realized that number 10 would have to be negative. Okay? So I think step one, and always calculate the absolute value bars first, is something that we should write down. That's your first step. It's kind of like parentheses. It's kind of like the order of operations, right? So here I go 2, 11 minus 15 is negative 4, but I call it 4 because it's absolute value. And then you do minus, and then you know that this is 26, right? So you kind of always have your eyes peeled for the absolute value bars, and whatever you can kind of immediately calculate, you do that. Again, don't ever distribute the negative inside. Do not, because you are not allowed to. Okay, think of it as the absolute value bars are really tall, and you cannot distribute inside them. They're not like parentheses. So really, this is 6 minus 26, which gives me a negative 20. It's possible to have negative values in these questions because there's minus signs outside, right? Here I'm getting 7 times 8, really, plus negative 3 times, well, 9 minus 20 is negative 11, but negative 11 is really positive 11, and then minus 18, because the negative 11 was an absolute value. So you just have to read it kind of carefully, look at it. Okay, this is going to be positive. This is going to be positive, right? And then whatever's outside is obviously outside. So 7 times 8 is 56. Negative 3 times 11 is negative 33. And then we have a negative 18. We could actually even calculate negative 33 and negative 18. And that gives me, I believe, negative 51, right? So really it's 56 and negative 51, which gives me a positive 5. For something like number 14, I know we really want to do 2 times 1/2. And technically that's what you can do, right? I would say look at how I convert my absolute value to just a parentheses, and I just convert them to its positive counterparts. And then I know that I need to multiply. This is 1 minus 3/6, which is in fact 3/6 or 1/2. Okay, and that brings us to something like number 15 and 16. When solving the equation absolute value of x equals 8, how many solutions occur? Explain your reasoning. Well, it's kind of like asking how many numbers on the number line are 8 units away from 0, right? How many numbers are 8 units away from 0? And obviously the number 8 comes to mind, but we also have to realize that negative 8 also would satisfy this equation. So really, when you have the absolute value of x equal 8, the first one that you have to write is x equals 8. The second one is x equals, you keep the first term the same, the equal sign the same, and you switch this number to its opposite. This only happens when you have the absolute value bars totally isolated. So when you're solving for a multiple step absolute value equation, like we're about to do in number 16, your goal is to always isolate the absolute value bars to its final form where it's only by itself. Once you do that, then you can split your answer into two separate answers. Every absolute value equation should have two answers unless it's set equal to 0. Or it's set equal to a negative, which is actually no solution, right? So something like number 16, solve the absolute value equation. Our goal is to isolate this variable and this absolute value box or bar, whatever you want to call it. We isolate it as much as we can, just like we normally would to solve an equation, solved for a variable, and then we split. Okay, so check this out. I'm going to get 3 absolute value of n plus 11. I know it says plus negative 11 in absolute value, but really that's 11. This is going to equal 20. Okay, so just like every two-step equation, our first step is to subtract 11 from both sides. Always get rid of the constant. That's kind of like what we've been doing this entire time, and this is no different. You then get 3 absolute value of n is equal to 9. Okay, our goal is to uncover what the variable is, but we first have to kind of isolate the absolute value bar. So we get absolute value of n is equal to 3. So now you can finally split, and you should realize, okay, well, the first equation is obviously going to be, or the first value for n that works is n equals 3, right? It's literally what it looks like. But the other one that you have to remember is just the opposite, because n equals negative 3 also has a distance from of 3 from 0. Okay, so when you split here, when you have an absolute value bar kind of totally isolated like this, you then want to split it into two separate answers. This is a very, very crucial step, and we'll see more of this as we move on. Okay, now some of you guys might be thinking, why? Why are there two values? Well, it's because really a certain distance will always have two possible terms that could satisfy that distance. If I said how many numbers are 5 units away from 0, the first number you would think of is 5, but then the other number that you have to remember is also negative 5. Okay? As we do this more, you will obviously be more comfortable with the idea of positive and negative answers for your absolute value. All right, thanks for watching.